Hello, today I'm going to derive the formula from arithmetic series. An arithmetic series is the sum of an arithmetic sequence, and an arithmetic sequence is a sequence that's got all the terms separated by a common difference, all the successive terms. So for example, we could have 3, 6, 9, 12, 15, etc, etc. We notice here the difference is always 3, it never changes. First thing we need then is going to be the first term, and we'll label that A. And then also we're going to need the common difference as well, which will give the symbol of D for difference. Common difference. Can be useful as well to know what the nth term is going to be, so we can help him write in our terms in a second. So we give that the symbol of U sub n, say the nth term, and that's going to be equal then to the first term, and however many times we've added on the common difference. If we think about the first term here, we've not had it added on at all. For the second term, we've added it on once, third term we've added it on twice, fourth term 3 times. So it's always going to be, we add it on n minus 1 times. Whichever position you're in, you add it on 1 time less than that. So let's write out our summation then. So Sn is the symbol for summation, or series in this case. And it's going to be then the first term plus the second term, which is going to be a plus d. The third term, which is a plus 2d, all the way through until the final term, which is a plus n minus 1d. Next thing we're going to do then is we're just going to rewrite the terms backwards. So write in the last term first, the second to last term second, etc, etc, until we have the first term right at the end. So we write that again. Sn is equal to a plus n minus 1d. The second term then in this order is going to be a plus n minus 2d. And this will keep on going all the way through until at the end we have a plus d, and a for the second term and the first term, if I'm over here. Next then, we're going to add these two lines together. So we have 2Sn on the left, twice the value we're aiming for. And now we'll add it term by term. So we'll see this first term here, it's going to this first term here. So altogether there's 2 A's. And how many D's are there? Well, there's 0 D's here and n minus 1 here. So in total, it's n minus 1. Lots of D. Doing the second two terms, we have a plus d and a plus n minus 2d. So how many A's are there? Well, there's 2 again. And how many D's? Well, there's 1 D there and n minus 2 of them here. So altogether, that's n minus 1 lots of D. This pattern is going to continue all the way through to the last two terms. When we add them together, there's 2 A's plus how many D's? Well, n minus 1 there and none down here. So altogether, that's n minus 1 lots of D. And we'll notice that all of these terms are identical, and there's n of them, so we can factorise the n out the front. And so we have n lots of 2a plus n minus 1 lots of D. And we still have the 2s on the left-hand side, 2Sn. And next step then, we're just going to divide by 2. So we have Sn is equal to n over 2, lots of 2a plus n minus 1 lots of D. And that's it. That's the formula. Beautiful.